Yes, hello. So, how are you all? My name is Yogesh, and we are doing standard 11th statistics. We had done quartile deviation in the last lecture. We had seen the three stages of quartile deviation when xi is given, when fi xi is given, and when classes and frequency are given. The formula for quartile deviation was q3 minus q1 upon 2, and coefficient of quartile deviation was q3 minus q1 upon q3 plus q1. Okay. So these were the formulas. What we had seen that if only xi is given, then you can find with the formula like value of n plus 1 upon fourth observation, and you have to find the number of observation in the sequence. Then it was about fi is given. When fi is given, you have to search for the CFI, and then you have to apply the formula that value of n plus 1 upon fourth observation. Then you have to continue with the classes. In classes, your formula for q1 was extended with this formula, that is L plus n by 4 minus CFI upon Fi into C. So now we will proceed with the next topic, that is. So after the quartile deviation, the topic is average deviation, which is known as mean deviation. This topic is reduced as per the guidelines of government. So we will discuss it later on in a very short manner. Now we are doing, so we will not do mean deviation now. Okay. First topic range also we had not done. That two topics which are reduced as per the government guidelines. We will be seeing it at the last stage of the chapter in a bit quick manner. Okay. We'll not skip anything 100%. Okay. But the topics which are in your syllabus will be solved as per the priority or will be solved first. Now, my next topic to this chapter is the standard deviation. So, this is the very important measure of dispersion. Okay, in this also you have to find standard deviation and its coefficient. Now, in this standard deviation, there are two formulas. That xi is given, fxi is given, fxi classes and frequency are given. This is all together one thing, but in only xi is given, there are two formulas. In fxi, two formulas. So there are two different ways to solve a single answer. Okay, so we'll be solving it with the both formulas specified. I'll teach you how to solve the standard deviation. First, we will be writing the formulas. So let's write. You have to take out your book, pen, pencil, calculator with you. So this my topic is standard deviation. Yes. Now this standard deviation means what? Or you can say what are the formulas for standard deviation. So formulas for standard deviation is equal to, we are doing the point where for raw data or ungrouped data. In short, you can say when only xi is given. So we are doing this particular thing for raw data or ungrouped data. Now for this there are two formulas as I told you. Standard deviation is equal to sigma x minus x bar whole square upon n root. This is sigma x minus x bar whole square root. Okay, so this is one formula. Then, or what is another formula? Standard deviation is sigma x square upon n minus x bar whole square. This is sigma x square upon n minus x bar whole square. So this is raw data or ungrouped data when only xi is given. So standard deviation is sigma x minus x bar whole square upon n's root, or standard deviation is sigma x square upon n minus x bar. Now your standard deviation, so we are doing. Hmm. So let us start with the sum, so you will understand what formulas actually are and how to solve the standard deviation. Let us start with very small digits. We are doing exercise 4.4, sum number 2. So now see, xi is given. As I told you that we'll do standard deviation with both the formulas. Okay, so first of all I'll take the first formula. In any case, in first or second formula, you need to find x bar. So x bar is sigma x upon n. X bar is sigma x upon n. This is sigma x upon n. Now what is sigma x? You have to do the total. 7 plus 3 plus 11. 7 plus 3 plus 11 plus 8 plus 9. So this is 38. Now what I'll find? I'll find x bar first, as I told you. It is sigma x upon n. So it is 38 upon. What is n? N is 5. So it is 38 upon 5. 7.6. Okay. Now this x minus x bar. 7 minus 7.6. See what I'll do now? Now I'll subtract x bar from all the x given. Okay, what is x bar? It is 7.6. What is x? It is 7. So 7 minus 7.6, that is minus 0.6. Then 3 minus 7.6 is minus 4.6. Then 11 minus 7.6, 3.4. Then 8 minus 7.6, 0.4. Then 9 minus 7.6, 1.4. Now you can check by totaling this x minus x plus column. It should be and it must be 0. So I hope you heard me correctly. It should be and it must be the 0. The x minus x bar is always 0. Yes. Sir, if this is 0, then why you found this? Actually, I want to find x minus x bar whole square. Okay, what I need to find? I need to find x minus x bar whole square. So now how to find x minus x bar whole square? It's 0.6 into 0.6. That is 0.36. Then 4.6 into 4. Then 3.4 into 3.4. 0.4 into 0.4. 1.4 into 1.96. Now this is 0.36 plus 21.16 plus 11.56 plus 0.16 plus 1. This is 35.2. Now this is x minus x bar whole squares total. So my total is 35.2. Now what I have to do? I have to write the formula. Standard deviation is sigma x minus x bar whole square upon n. Now the sigma x minus x bar whole square is 35.2 upon n. So my standard deviation is 35.2 upon 5 is 35.2 upon 5. So standard deviation is 7.040. 2.65. This is my standard deviation. Okay. Now now this is standard deviation with the first formula. We have written two formulas initially. Okay. Yes, we had two formulas for standard deviation. One is sigma x minus x bar whole square upon n's root. Another is standard deviation sigma x square minus sigma x square upon n minus x bar. So this we had done a first formula. Now in the same sum, we will be writing the another formula. So initially the things are same. Your x bar is same. Now what you have to find in last formula, what we had done, we had solved the x bar. Then we have found x minus x bar. Here we have solved x bar, but we will not find x minus x bar whole square. We will find directly. We will be finding directly the xi square. So we had done directly square of xi. Okay, so 7 square 49, 3 square 9, 11 square 121, 8 square 64, 9 square 81. Now I'll be doing the total of this is 324. So this is xi square. Hmm. My standard deviation is sigma x square upon n minus sigma x whole square. Okay, so this is sigma x square minus x bar whole square. Now my standard deviation is sigma x square 324 upon n minus x bar whole square. So I hope you got what I'm doing. Yes, sigma x square we had found. Okay, xi square 324, n is with us and x bar was already with us. Now we'll solve this formula. So standard deviation is 324 by 5, 64.8 minus 7.6 into 7.6 is 57.6. Now 64.8 minus 57.76, 7.04. Now this root of 7.04 is 2.65. So you can see that we got the same answer in both the formulas. We got 2.65 in the first formula and 2.65 in the second formula. So when to use which formula? There is something like that you have to use this formula, this formula. So listen me very carefully. I am telling you that as answer is same in both the formulas, obviously there is no compulsion or you will not be asked that you have to find standard deviation with this formula only. So there is an option to find with any formula. Now I'll tell you that when it's easy to find with which formula. Okay. When you get x bar in fractions. See, this x bar is in fraction, that is 7.6. It's not 7 or 8. In this kind of case, generally, I'm using the word generally, this formula is very easy. Why, sir? Because in this 7.6, so these all are in fractions and the square of this is in fraction. So compared to this, this particular is very easy because you don't have to use that fractions. Sometimes telling you the other point, sometimes digits are very large. Okay, see, these are 7 3 11, so it's quite easy, but it's our 100 200 300 term. In that case, if you find an xi square, the answer is quite big in number. In that case, if you find mean as a non-fraction, then you can use this formula. So it is as per our judgment and our own calculations that how my calculation will be easy in which formula so that I can opt the one. That is our for our personal judgment. And in case you don't understand the judgment part that when to use which formula, forget about it. Use any formula, you will get the answer. You have calculator in your exam, so don't worry about the calculations. Okay, you can do it very easily with any kind of formula. Okay, no big digit is deal for you. Okay, so let us do the another sum. So let us start the next sum. Now we'll be doing 4.4 first, or let us take a sum from illustration. Now we can solve with one formula. It's very fine. It's not necessary to take the formulas. Let us find illustration number 12. The runs scored by batsmen in last 7 matches are given below. So runs, that is X. 52, 58, 52, 58, 50, 60, 54, 38. What is total of this? XI? 52, 58, 60, 54, 38 and 40. Total of XI is 350. In the very first stage, what I'll do, I'll be finding the X bar. X bar is sigma X upon N. Now what is the sigma N? 350 upon 1, 2, 3, 4, 5, 6 and 7. 350 upon 7. So my X bar is 50. Now I got X bar is 50. I told you that when X bar is non-fraction, then the first formula is very easy. That is to find X minus X bar. So 52 minus X bar is 50. 52 minus 50 is 2. 58 minus 50 is 8. Minus 10. 10. 4 minus 12. Minus 2. As I told you that please check this X minus X bar so that we are sure that we are going on the right. Total must be 0. If it doesn't come 0, then you had made some mistake somewhere. After finding this, we will be X minus X bar whole square. What is X minus X bar whole square? 464, 100, 16, 144 and 4. So my total is 464, 100, 116, 144 and 4. So my total is 430. Let us check the total once again. 464, 100, 116, 144, 4 and yes, it was up to here. 464, 100, 116, 144 plus 4. 432. Now let us write the formula. Standard deviation was sigma x minus x bar square upon n's root sigma x minus x bar. This is 432 upon what is n? Plus 7. 61.71. What is root of 61.71? This 7.80. Now the 7.85 is runs. So you can say your standard deviation is 7.85 runs. We can check the answer. Yes, 8586 is. So you have to write this sentence that standard deviation of runs scored by batsman is 7.86. You can solve this sum with the another formula also, which we had done in the previous sum. You can use with both formula, any formula comfortable to you. In exam, you have to do only one formula of your choice. Answer is same, so there is no another confusion. So in next lecture, we'll proceed with this standard deviation. Till that, you have to write everything what I taught you today and learn the formulas so that we can proceed very easily in the next lecture. So that's it all for today. Thank you.